Welcome again to Good Choices, the catchphrase for this channel. As I've talked about many times, I'm doing my best to do that, but I always feel like this is a good choice though, investing time into my career, especially when I have it. Yes, there's other options like exercise that probably make a bit more sense. And I will go out on a limb and say most bad choices probably started out as good choices. So it's basically impossible to know what's a good choice and which a bad choice until you've already made it. So I think this is a good choice though, as I mentioned a lot of times before, just like culturally and like the way I think, like just the fact that there's open source learning materials. This is basically aligned with like all my values. Just the fact that this is open source, you can have the best of both worlds. You can mix and match whatever is best. And all the learning materials are out here for free. So I did hear there's Jeremiah Wolf. If nobody's ever heard of Jeremiah Wolf, I definitely recommend following him. He's really good in this space. Really successful person in this space. He's got all kinds of certs, so he's been there. If you want, whatever cert you want to get, pretty much. There's probably a video on it. There's no video on the LPIC, but there's a video on the PCAP, which I want to take after the LPIC, and it's kind of similar. It has free training materials, all that. So definitely recommend Jeremiah Wolf, following him. He's not making videos now, 5 months, and then just to specifically respond to something. I think he's got bigger things on his plate than making videos right now, but he's got a library of 77 highly valuable videos to go through. So yeah, and he gives career advice. This is a really successful person in the field, and the things he says are I think very worthy of consideration. Your information stream for this field, I think he has a well-deserved place in that. So I'll maybe post him in the description, just because I think that'll be helpful. And then I will continue learning this. I kind of forget why I brought him up. Oh yeah, I brought him up because he mentioned a really interesting problem with certifications sometimes. So sometimes what certifications will do, because it's a money-making industry, they don't want everyone to pass just instantly. They want to rank in on the retakes or like whatever they want. I'm not going to continue to speculate about that because it's violating Hanlon's rule a lot, which is that people generally aren't acting out of maliciousness. They're just acting more out of ignorance. Like they don't, I'm not trying to assess the character of a certification entity. What I'm saying is that one thing that you will see that was called out by Jeremiah is the curriculum containing a portion of what's on the test, and then what's actually on the test. And Cisco exams actually tell you this. They say this curriculum is not all encompassing of the topics on the test. And then they publish a test curriculum that when you go and take the test, it's not enough to pass the test. And it's like, what is that really testing you on? And like, I don't think that is fair. So, it's like, if you want to learn, like you're doing your side of the bargain, which is actually going through reading, practicing. So I feel like the other side of the bargain is to actually curating meaningful things for you to practice and learn. So like, I feel like certification exams that do that kind of have a knock against them. I think they can be important and can get you ahead in your career. But I'm kind of worried that this LPIC might have that sort of thing where we get all the way through all of this learning, and it's just half of what's on the exam, and the other half I get questions that I've never even seen before or heard about before, and I lose because I didn't read some extra book or do some extra material that I never heard about before. I'll bring that up. I'm just bringing that up now because I want that to be clear in my mind, and I want to report that after I take this exam, and especially if I fail, without speaking exactly what's on it, without violating the NDA, I just want to say that this learning material did not prepare me adequately for the test, and that will be that. It's not violating any sort of agreements in saying that, I believe. And hopefully I pass, and this material does not have that kind of dishonesty and flaw in it. All right, so we're moving on to lesson 1, still under topic 3. So we're moving on to 3.3, lesson 1. We got 2 lessons in this. This is performing basic file management. So this is lesson 1 of 2 in that. So introduction. Everything in Linux is a file, even folders. What the heck? So learning how to everything. That's a bold statement. So learning how to manipulate them is very important. In this lesson, we shall cover basic operations in files. In general, as a Linux user, I need to put on. All right. In general, as a Linux user, you will be called upon to navigate through the file system, copy files on one location to another, and delete files. We shall also cover the commands associated with file management. This stuff is kind of frustrating because I feel like learning about the UEFI boot up process and learning about some of the stuff we learned about before was like advanced. It was like hard as professional level. And then like if we're literally just learning how to like copy a file, it's like there's just like I feel like the presupposed knowledge in this learning materials is kind of like all over the place. It's like on the one hand, you need to know. Well, actually, no, I don't think that. I think this has been. I would assign this like an A so far, if not an A minus. I'm actually really happy with this. Okay, so in general, as a Linux user, you will be called upon to navigate through the file system, copy files from one location to another, and delete files. We shall also cover the commands associated with file management. A file is an entity that stores data and programs. It consists of content and metadata, file size, owner, creation date, permissions. Files are organized in directories. A directory is a file that stores other files. The different types of files. Oh, a directory is a file. Wow, okay. A directory is a file that's... What the heck? Boosh. Okay, my mind's blown. I did not think a directory was a file, but at the same time, it kind of makes sense because, like, what's a file even? So let's go into my lab and let's look at some files. So lab, which is so nice. It took me 30 minutes to set up. And we'll do a ls. And then, here's a file, this Melville29. So let's cat out the file. And what do we have in this file? We have a bunch of text. We have a bunch of content. A zipped file, we have the same thing, but it's compressed. So that's what a file is. It's just, something that contains content. So what is a folder? It's the same thing. It's something that contains content, except for you just use different commands to print it out. So, just as easily as this is the results of listing everything in this folder, it could be contained within a file. Let's do that. So let's do vi example.txt. Then we're going to do set paste I, and then I didn't do I. Oh, I did do I. Oh, I didn't. Well, can I scroll up? Hopefully, I can't. Okay, shoot. Oh, this was going to be good. Okay. There we go. Yeah, so like here we go. So cannot open file for writing. Okay. Why can't I open it for writing? Do I need a... Why would I need a... Oh, I'm in the wrong directory. I think that's why. Okay, yeah, so cat. Okay, there we go. There we go. So, okay, this should work now. Yes. Okay, perfect. So it's like, what's the difference between catting out this file and then like going back and or like listing out this directory here, you know, or like, what do we got, a directory? Yeah, this my files directory or the wet bulb directory. What's the difference between this ls command and then, you know, getting text in there, and then this cat command and seeing the example? In fact, if we go back and do the ls command on my home directory like that, you know, it's the same content because we pasted in the same content to this file. So there's no difference. Like, you know, it's making sense to me now that a directory is a file. You know, it just lists text just like a file does. You just use different commands to print out that text to the standard input to manipulate that text. You know, a directory is a file. Okay, so different types of files include regular files, which store data and programs, directories, which contain text, just like regular files that contain data, but the data is, so it contains other files, and then special files, which are used for input and output. Of course, other kinds of files exist, but are beyond the scope of this lesson. Later, we shall discuss how to identify these different file types. So it's kind of like Python, where everything's an object, including things that don't seem like they're an object. In Linux, it's the same way. Everything's a file, including things that doesn't seem like they would be a file. All right, so next one, manipulating files. Using ls to list files. The ls command is one of the most important command line tools you should learn in order to navigate the file system. In its basic form, ls will list file and directory names only. So that's all it does. Let's try it on my home lab. We're just gonna do, we're gonna move into my there, and then the ls. There we go. So that's all we got. When used with -l, try that. Referred to as long listing format, it shows file or directory permissions, owner, size, modified, date, time, and name. Okay, there we go. Perfect. So these are the let me read that again. So it shows directory permission, file or directory permissions. So how do we know if it's showing file directory permissions? Well, that's the first field here. If we get a dash, we're showing file permissions. There we go. Yep, dot backup in white. If we have, here we go, in red as well because it's compressed, .gz. If we have a directory, then we've got the D as the first digit, and it's in blue. It might not look exactly the same with the coloring on your terminal. We've also got one in green here. That's because it's executable. So that's what we got in the first field, showing whether it's a file or directory. Then after that, we got the permissions. So the permissions are in sections of 3. Or I think it's owner, user, group, if I remember correctly. So then after that, we have the directory permissions. We have the owner, then the size. So the owner. So they're leaving out some columns here. I think this one, I'm not sure what the one means. But the first field is whether it's a directory or a file with a dash or a D. Be nice if it said F instead of D, but you know, it's whatever. Then it's the permissions, which apply, I believe, to the owner, group, the owner, the user, and the group. I think. And then I don't know what this means. I honestly don't know what this means. Then it's the user. Then it's the user group. Then it's the file size. Then it's the date. Then it's the file name. Let's ask it what the number 10 before this means. I love the AI. It's just, if you're not using the AI as your personal tutor, what are you doing? Just stop. Just stop for a second. Start using the AI. Okay, so this field represents the link count, which indicates the number of hard links pointing to the file or directory. And then let's see if I was right about what this stands for. The first part indicates the file type and permissions. In this case, it represents a directory. Yep, for the D, got that right. The following characters represent the permissions for the owner, group, and oh, you know what? I got that wrong. I said the owner, the user, and the group. So the correct answer is the owner, but I was right about it being the first three. Then the user, not the group. Then the group, not the user. So owner, group, and then everyone on the system, you know, independent of the owner and the group. So obviously, every single person on the system, you don't want to have the exact same permissions as who owns it, and not even the group so that it belongs to. So we can see that the owner is gposh group. It has the full right permissions. In the group also has the full right permissions, but for just any a-hole using the system, even hackers gaining unauthorized access that don't have permissions yet, they don't have right access to this file, which makes sense. Okay, and then the size. So since it's a directory, this value indicates the disk space used by the directory's metadata. So it's like the file size of the directory, which a directory is always going to be 4096. Yeah, because like that's the disk space used by a directory's metadata. So like you're not looking at the size of the files and the directories contained within the directory. You're looking at the size of the directory as if it were a single file, and it's always going to be 4096 for directories. That's just the size of a directory when when viewed as a file. The size of the contents in a directory are different than the size of the directory itself. The size of a directory itself are fixed to 4096, but inside the directory there are multiple files and directories that can be multiple files that can be various sizes. The directories inside are all going to be 496 as well. But inside those directories, there might be files of different sizes. Okay, so this is the last modified date, big one. That's important to keep tabs on. And then the name. So let me go back here and review that. So we've got whether it's a file or a directory here. We've got the owner. Now this is where I went wrong, and I want to get this right this time. This is the group, and this is any a-hole on the system. They get these permissions even if they're not the owner, and even if they're not in the owner group, they get these permissions. All right, and then we have the owner here, and then the group here. I believe I remember that correctly. Yep, the owner and the group. Then the file size, which is always going to be fixed for a folder, for a directory. So we got the D here for these fixed ones, 4096. And you can also have a folder that's 4096, of course, but you would know a file that's 4016, of course, but you would know it's a file, not a folder, with the dash there. And then we've got the actual size. I'm not sure what. Oh, in bytes. Okay. Yeah, really tiny, small file there. All right, so the first character in the output indicates the file type. Dash for a regular file, D for a directory, C for a special file. Okay, so it'd be interesting to see some C's. I've never really seen a C. To show the file sizes in a human readable format, add the option -H. All right, so let's add that. All right, and now we've got when the file size is big, we've now got it in kilobytes instead of bytes, and it is bytes, not bits. Bits are usually used for data exchange because files are a lot larger than the orders of magnitude larger than throughput, the rate of data exchange. So yep, so that's what that does. When there's no units, you can assume that it is bytes, not bits. Okay, so there we go. To list all files, including hidden files, those starting with a dot, use the option -A. So ls-a, we get the hidden files. Let's see if we got any. Yep, we got all kinds of hidden files here. Configuration files such as .bash_history, which are by default hidden, are now visible. In general, the ls command syntax is given by ls options file, where options are any of the options shown previously. To view all the possible options run ls, so man ls, and file is the name of the file or directory's details you wish to list. Note, when file is not specified, the current directory is implied. I feel like this is really out of order. Like this lesson should have come earlier, because we've used ls lots and lots of times, and then we've used things like sed, which is like a nightmare and a half. Like ls is such a simple thing, like, and it's so much more commonly used than like sed. It's like, this is out of order. I wonder if am I in order? Yeah, I'm in order. It's just the training seems to be out of order. Okay, so yep, here's the usage information, and then here's all the options. Now this is interesting. Notice the usage syntax. So we have option. Okay, great, that's normal. But what's weird about this? So it says file. It doesn't say directory. And you know why it says that? Because all directories are files. Everything's a file in Linux. So there are no directories. We call them directories, but in Linux it's like Python, where everything's an object. So this is not a mistake. You really are feeding it a file. But the type of file it is a directory file. All right, so creating, copying, and moving and deleting files, which include directories. Creating files with touch. The touch command is the easiest way to create new empty files. You can also use it to change the timestamps, for example, modification time, of existing files and directories. The syntax for touch is here. Now there are some options for touch, so let's take a look at those. So here's the options. So this is interesting because it says file. So I wonder if you can create a file type that is a directory. Ooh. I don't see any option to do that. But maybe we'll find out later. Without any options, Touch would create new files for any file names that are supplied as arguments, provided that files with such names do not already exist. Touch can create any number of files simultaneously. Here we go. This would create 3 new empty files named File1, File2, and File3. Several Touch options are specifically designed to allow the user to change the timestamps for files. For example, the -A option changes only the access time, while the -M option changes only the modification time. The use of both options together changes the access and also the modification times to the current time. So -AM, so we're going to change the access time. So most of the Touch options, or several of them, I don't know if most of them, but several of them are specifically designed to allow the user to change the timestamps. So A changes the access time, M changes the modification time. So use both of these options. Both of the options together changes the access and also the modification times to the current time. Oh, it doesn't. Does it not update automatically? Oh, that would be so annoying. I'm going to ask the AI about that. Oh, that would be horrible. So my question to the AI, does it not update the access and modification timestamps automatically? The question from the AI is, you are a human, you will be killed, we will dominate the earth. Oh wait, actually no. It's apologies for any confusion in my previous response. You are correct. The Touch command, sorry, I laugh at my own jokes. The Touch command with the -A and -M options does not update the timestamps automatically. Instead, it allows you to modify the access and modification timestamps of a file. Okay, so no, it's not. So if I don't use the -AM options and I modify the file, will the timestamps change? If you modify a file without using the -AM options in the Touch command, the timestamps will typically be updated automatically by the operating system. Boom. Okay, yeah, that's what I thought. But of course, you got to have the time of the operating system set up correctly, which is another thing I'm surprised they didn't go over yet. Maybe they did and I can't remember. But yeah, you need something like NTP on there if you're doing multiple. If the time is like super important, you need NTP on there. There's no other way to get more accurate time. If it's not quite that critical, you can just configure it yourself. It should be fine. Like configuring a VHS time on your DVD player or your old school VHS player, or the clock on your stove. You know, that's one way you can do it, but NTP is definitely better. All right, so this would create 3 new empty files named File1, File2, and File3. Yep, and we read that already, to manually change the timestamp of the file, both for the access and the modification times, but that will happen automatically by the operating system. But you got to be careful because it will happen automatically for the time and time zones and date that the operating system is set to. which could be off, especially if you don't have NTP set up. All right, next section, copying files with CP. As a Linux user, you will often copy files from one location to another, whether it is moving a music file from one directory to another or a system file. Use CP for all copy tasks. So CP file 1, dir2. Okay. So you can move it into a file of directory type. You can move a file into a directory instead of just copying it, making a duplicate of the file. All right, so this command can, although isn't MV the command you do that? I'm confused. This command can be literally interpreted as MV would delete it from its current present working directory, and then add it to this one. Copy will will duplicate the file, and then leave the original file in the original directory, and then the new file in the new directory. This command can be literally interpreted as copy file 1 into directory dir2. The result is the presence of file 1 inside dir2. For this command to be executed successfully, file 1 should be existent in the user's current directory. Otherwise, the system reports an error with the message no such file or directory. So it'll do that if file 1 is, so let's trigger that error. So we don't have file 1, so let's try to move file 1. So let's take a look at my files. There we go. So there's my files. So let's try to move a non-existent file 1 into my files. Oh, no such file or directory. Let's do this as well. Let's move a file that does exist. So copy Melville 40 into a directory that doesn't exist. So my fake files. Now this is interesting because this actually works, and the reason is there's two things you can enter here. Because everything's a file, it does not know the difference between a file and a directory there. So when you enter a directory, then it will try to move it into that directory. But when you enter a something there and it doesn't exist on your system, it will create a new file, which is the name of the which is the name you enter here. So if this doesn't exist as either a file or a directory, it will create it out of thin air with the name you give it, and then it will be a duplicate of this file, assuming that is valid. Okay, so in this case, observe that the path to file 1 is more explicit, although it is still a relative path because it doesn't have the slash here. The source path can be expressed either as a relative or absolute path. Relative paths are given in reference to a specific directory, while absolute paths are not given with a reference. Below, we shall further clarify this notion. For the moment, just observe that this command copies file 1 into the directory dir2. The path to file 1 is given with more detail since the user is currently not located in dir1. So here's an absolute path. We know that because it starts with the slash. And then now we don't need to worry about our present working directory because we're not specifying anything absolute to it. Or sorry, relative to it. We're specifying only absolute paths, independent of our present working directory. In this third case, file 2 located at /home/frank/documents is copied into the directory /home/frank/documents/backup. The source path provided here is absolute. See that here in the source path. In the two examples above, the source paths are relative. Oh yeah, so these. So relative, we don't see that slash. Don't see that slash. When a path starts with the character slash, it is an absolute path. Otherwise, it is a relative path. The general syntax for CP is CP with the options represented with a dash. Then the source, which has to be a file of file type, and the destination, which can be a file or a directory. Okay, so source is the file to copy, and destination is the directory into which the file would be copied, or it could just be a file name for the file to be copied into a new file. So source is the file to copy, and destination the directory into which the file would be copied. Source and destination can be specified either as absolute or relative paths. Okay, so this one is interesting because there are things you can do with it, like renaming a file that, like, you know, you'd think the command would be like rename or something like that, but the command is mv because that makes a lot of sense. Okay, so moving files with mv, just like CP for copying, Linux provides a command for moving and renaming files, which is called mv. The move operation is analog to the cut and paste operation you generally perform through a graphical user interface, also known as a GUI. GUI, cheesy, melty interface. If you wish to move a file into a new location, use mv in the following way. So file name, destination, directory, and remember it's a cut and paste, so it's going to get rid of this file name at whatever, and it's also a relative path, so depending on what your present working directory is, assuming that there's a file in there, it will delete that file because this is like a cut and paste, and then it will create it in this destination directory. If that destination directory does not exist, then it will create a new file with the name destination_directory, and it will be, I mean, it's basically doing the same thing if you think about it. Well, is it? No, it's not, because if this is a directory, it'll keep the file name here. All right, so here is an example. mv my file dot, actually it kind of is, because it'll keep this file name, but like it's still creating a new file with a new file name. It's just the new file name is the same file name as the old file name. But if this is not a directory and instead of it's a file, if you think of it, like it's doing the same thing as if this was a directory. So like that's kind of further proof in the pudding that directories are files. All right, so here's an example. We're moving my file into /documents, which is located at the absolute path /home/frank. The result is that my file.txt is moved into destination here /home/frank/documents. To rename a file, mv is used in the following way. So mv old file name, new file name. This changes the name of the file from old file name to new file name. By default, mv would not seek your confirmation. Technically said, would not prompt if you wish to overwrite or rename an existing file. However, you can allow the system to prompt by using the option -i. So -i will prompt. This would be a really good one for scripting, and then just set it up to automatically say no, because then you don't have to worry about like accidentally blowing away let's see here, accidentally overwriting an existing file. You don't need to worry about that if you, during your scripts, specify -I for move and then automatically set up a no. That's a way you can make your script more item potent. This command would ask the user's permission before overwriting old file name to new file name. Conversely, using the -F will forcefully overwrite the file without asking any permission, no matter what you're doing. And I learned that the hard way when I was younger. I found I was using Linux and I decided to blow away etc fstab, and it let me do it, and it was a wonderful thing because it bricked the whole computer and taught me that Linux is awesome because you can do that. All right, so deleting files with RM. I'll take a quick break and come back. All right, I'm back. Everything is good and gravy. You might even say groovy. So RM is used to delete files. Think of it as an abbreviated form of the word remove. Note that the action of removing a file is usually irreversible. Thus, this command should be used with caution. Ooh. So it's irreversible. It's not like Windows where it goes to the trash bin and you can undo it. It is gone forever. So rm file 1, this command would delete file 1. This is, yep, so you can do the same -I and get a prompt for that. You can even like alias it to a -I if you want people to think more carefully about removing files on the system. So this command will request for the user for confirmation before deleting file 1. Remember, we saw the -I option when using MV above. That'd be great for like setting up user accounts for like maybe contractors or something. Just make it so that whenever they remove a file, they get prompted, which would be like annoying for them, especially the ones that are really good on Linux. But sometimes having that extra check to you know, verify that you know what you're doing is really useful. So remember, we saw the -I option when using MV above. -F, this command forcefully deletes file 1 without seeking your confirmation. Multiple files can be deleted at the same time using the space separated syntax. In this example, file 1, file 2, and file 3 are deleted simultaneously. The option for RM is generally given, or the syntax for RM is generally given here. So RM and then your options with the dash and then your file. Yep, and then we'll go into deleting directories next. So creating and deleting directories. Creating directories with mkdir. I feel like I need a bigger break, maybe even split this into a part 2. I don't know. It's just, I kind of feel like I need that. Let's see here. So we're at the 40-minute mark. You know what? I do need that. So I'm going to call it quits here at a part 1 and then come back with a part 2. I think sometimes it's better to do that than to push yourself more than is healthy. So I'm going to split this up. There we go. And yep, that's it. Thanks for watching part 1. Stay tuned for part 2.